So now we're going to talk about similar triangles, and really it works for similar figures, but we're going to be using triangles. But you could apply the same principle to a square or a octagon or something like that. Okay, so think of like this large triangle here, and it has a certain shape and it has certain measurements. And then you're like putting it on a copy machine and then reducing it to this smaller triangle. Well, the sides are proportional to each other. So like the 16 is proportional to the 4. So see how I used to have the 16 over 4? And it has to be the same for the other sides. So the 12, do it in a different color, the 12 is to the 3. And so that's that one. And then you have the 20 is to the 5. And that's that one. And all of those have to be equal to each other, okay? So another way to think of it is, think of drawing a triangle on a balloon, and then you blow the balloon up. You're going to have a triangle still, and it's going to be the same shape. The sides are just going to be longer, and they do that proportionally, okay? So we refer to them as similar triangles. And now here we have an example. So on a map, San Francisco, Las Vegas, and Los Angeles form a triangle. So that's my map here. Here's San Francisco, Los Angeles, Las Vegas, and Los Angeles. Okay. The distance between the cities is measured in inches. The figure on the left below represents the triangle formed by the cities, on the map. If the actual distance from Los Angeles to Las Vegas, so this distance right here is actually 270 miles, find the distance from Los Angeles to San Francisco. So we're trying to find this distance here. That's going to be our X, our question mark. So you might wonder a little bit about the 3 sides of the triangle. Well, we only need 2 sides to work with. So it's a matter of how they compare. So they're similar triangles. You have the one on the map, so a small version, and then we're trying to like blow it up into a large version so we can actually figure out how many miles it is, okay? So we'll start with the small one. I'll compare the 1 inch. So I'm going to compare small, I guess the map. That's a better way to say it. The map to the actual, the large. I mean, both triangles look the same size in our diagram, but we're comparing the map to the actual. So the side from Los Angeles to Las Vegas is 1 inch, right? Sometimes it helps to put the units up here, so we're measuring in inches up here and miles down here, okay? So 1 inch is to the 270 miles. And that's got to equal, and now here comes the stuff we don't know. So the small map, the 1.3, so 1.3 inches to X. That's the one we don't know. So you have to be consistent. I have to always put the inches in the numerator and the miles in the denominator. Now, if you're saying, well, I wanted to put miles in the numerator, that's fine. You just have to be consistent, and it'll all work out. Proportions are fairly forgiving. You know, you just have to make sure you are consistent with what you're doing. Okay, now we can do the cross multiplying. So 1 times X has to equal 270 times 1.3. So I'm going to have X equals, and then to be really honest, I probably would pull out a calculator here and go 270 times 1.3. And I'm getting 351. Oops. Okay, so what does that mean? It means 351 miles, and that's the abbreviation for miles, MI, from Los Angeles to San Francisco.